All right, so here we go. How do I start this? Yeah, the same way I start everyone, right? I'm saying PI equals PF. Now, so I want to look and see what I have. I know that I have this momentum here, this momentum here. I have two dimensions. So what must the momentum, I know I have this momentum in the X, PIX equals P, and I have PIY equals PFY. So what must be true about those? It has to be the same, yes? Whatever I had in the X has to be the same in the X afterwards. Whatever I have in the Y has to be the same in the Y. So, but do you see the trick here? The trick here is, the best way to do this is to look at it as a vector. This vector is I do it over here in yellow. Let's say that's 4,000, so that's going to be whatever, 4 times 10 to the 4th meters per second. So this vector is 4 times 10 to the 4th kilogram meters per second. Okay, and then that has to stay there. So your final answer has to have that same vector. Then this vector is 3 times 10 to the 4th kilogram meters per second. Does that make sense to everybody? I think it is. Right, because it's 20, like 2 times that would be 3,000, so 20 times that would be 30,000. Okay, how's everybody doing? Then using the parallelogram method, my resultant should be this. And if this side is indeed 3 times 10 to the 4th second, hello, what is the hypotenuse? Yeah, it's got to be 5 times to the 4th kilogram meters per second. So I know this angle to be 37 degrees, or approximately. It's like 37.3, I think. Now, so is my velocity 50,000 meters per second? No, what do I have to do? See, so I know I've calculated my P final. And my P final, the magnitude of my P final is 5 kilogram meters per second. That equals the total mass times the velocity. So I have to divide by the total mass. And what is the total mass? It's 5,500 kilograms, right? So I have to divide 5 times 10 to the 4th. So my velocity is going to be 5 times 10 to the 4th kilogram meter per second over 5.3 kilograms. Kilograms will cancel. This goes away. And this becomes like 50. So 50 divided 5, which is whatever that is. Something, I don't know. Yeah. 9 point what? 9.1 meters per second. Boom. So do you see? Our momentum in the X was only from the truck. It's the momentum of the truck. So the momentum caused by the truck is going to be the same as after. But afterward, because they're stuck together, you're saying it's the kind of like, I don't know, the crash momentum in the X. And then the momentum in the car, right? And then that's going to be the crash momentum. Ah, jeez, these are bad variables. I know, I'll say final. And that's going to be final momentum in the Y. See, so this momentum became a component of the final momentum. This momentum became a component of the final momentum. And our final momentum is that orange 5 times 10 to the 4th kilogram meters per second. And then we use the total mass to get yeah.
What did you write for V?
Oh, for V equals, I just said V is kind of like the total momentum over the total mass, right? And then that total momentum was that times 10 to the fourth kilogram meters per second, and the total was 5.5 times kilograms. All right, any questions? Yeah.
What is, it says 5 times 10 to the power 4 kilogram meters per second over mt equals what?
Oh, it means, what I did is I said the total momentum is 5 times 10 to the fourth kilogram meters per second. I said that equals mass total times velocity. Then I divided both sides by the velocity, the mass total to get the velocity. Okay, any other? Okay, so now